Hey guys, welcome back to the channel, and let me just check if we are live. Hopefully we should be. I'll just check. Yep, we are. Okay, then let's start off with today's lecture. So the problem that we are going to discuss today is check if linked list is palindrome. Okay, so what are you given in this problem statement? Given a singly linked list of size n of integers, your task is to check if the given linked list is palindrome or not. So for that, let's first understand what is a palindrome, and then I'll continue with the question. Okay, so a palindrome is nothing but any string or any series of characters which, when read from left to right, for example, if this is the case, when it is read from left to right, it is 1 to 1, and when it is read from right to left, that means from in this direction, right to left, then also it is 1 to 1, right? So when it is the same number both ways, it is known as a palindrome. A string, for example, can be a palindrome. If I write a string like this, A, B, C, B, A. So you can see that A, B, from left to right also it is same, and from right to left also it is same. So this is your palindrome. Okay. Now, how can you determine in case of a linked list if that is a palindrome or not? Okay. So let me take this example. So for example, we have give me a second, just a second. Yeah, 1, 2, 3, 2, 1, right? For example, this is a linked list given to you. This is your head node, right? And this is your tail node. Now, what we have to do, we have to check if it is a palindrome or not. Fine. Just imagine in case of, for example, if it was an array of integers 1, 2, 3, 2, 1, what would you have preferably done? What you could have done, you could have used 2 pointers probably, because our target is to check if this value matches the last value, then this value matches this value, and since this is an odd number of numbers in this, the middle one does not need to be taken, means it will obviously map to itself, right? But what is the challenge when we are trying to do the same approach in case of a linked list? So the challenge in case of a linked list is that, for example, if I have 1, 2, 2, 1, the challenge is that, for example, even if you take a pointer, let's say this is your left pointer pointing at this head node, okay, and you have your right pointer pointing at the tail node, fine, and you want to move one step ahead of left and one pointer behind of right. The issue is that each node is having a address to the next pointer. So left, I'll move ahead and I can compare, but what about right? How do you get the address of the previous pointer unless you take one more pointer to keep the track of previous? So this thing is a challenge when we are trying to do for a linked list. Okay, so what could be the possible brute force approach that you can try? Basically, now you know what we want to check. We want to check if the node values, the last one is to traverse until you reach the null node, right? What I'm going to do, I am going to insert each node into my stack. So I'll be here. This is, for example, your temp node. Now your temp moves to this node, and you push this into your stack, then you move to the next node, you push it to the stack, move to the next node, and push it to the stack. Now you will wonder why we are doing this. So we are simply doing this because we know that stack follows last in first out. Now our comparison will be easier. Why? Because we know that node at the top of the stack will be actually the last node. So now I'll simply do one thing. I'll again iterate over this linked list starting from the first node, and I'll keep checking the data of this node at which temp is pointing and the peak value of your stack, right? So 1 is equal to 1. So I remove pop from the stack and move your temp to the next pointer and repeat the same process unless you find a value which does not match. That means it's not a palindrome. This value matches this value, you remove it from the stack, move your temp to the next pointer. This 2 matches this 2, remove from the stack, move to the next pointer. This one matches this. Now it is the end of your linked list as well as your stack is empty. You haven't found a mismatch so far. That clearly means you will return true. So what does your question demand? You will see that, I'm sure that I assume that you guys have already read the question before you come here. So what are you given in this? That you are given this function which is supposed to be completed, right? So the return type is boolean. You just have to return a true if it is a palindrome. If not, you return a false. Got it? Okay. But the issue with this approach is that we are using an extra space. Okay, and we can still do better in terms of space, and also we are traversing over this linked list how many times, although time complexity will be big O of n, but if you see, it's not a one pass solution. We are traversing over your linked list once when we were pushing it to the stack, and once again when we were comparing it from each of the nodes in the stack. So 2 traverses. Okay, but the point here is we are using an extra space for stack. Can we do it without using any extra space? Without extra space. So that would be a better approach, an optimal one. Optimal approach would be what? So see, without extra space. What are we going to do in this? This is 1 pointing to 2. This is a palindrome that I'm writing in front of you. So my aim is to actually check the second half if that matches the first half. In what way? That this should match this value, this should match this value. So one thing is clear, that obviously I want the second half of my linked list to be similar to the first half, but not in this order. If I reverse it, for example, if I reverse this part, okay, so what kind of REVERSE, okay, so what kind of a linked list are we going to get? We are going to get 1 point, next node is 2, and now for example, if this is your separate linked list, you just have to traverse over this linked list, this first half, compare it, you find a match, you move to the next pointer, compare it, find a match, and that's the end of your iteration. Now, so I'm sure that it is clear to you what our approach is going to be. So what we are trying to do, we divide our linked list into 2 halves. Then the second half, we actually want to map it with the first half of the linked list. So for that thing, we reverse the second half of linked list. Now you already know how do we write a reverse function, right? But before that, this is your second step. The first step is you find the middle of the linked list. Find mid of linked list. Why we are finding mid of linked list? Because how will you know which second half I need to reverse in order to match the values? So for that, now I'm starting off, and once you have done the reversal, the next step is simple. Just iterate over both the lists and compare the values. If it's a mismatch, you return false. Now let's go one by one. Both these things we have already solved in as a complete problem in our previous questions of this linked list section while we were discussing. So if you have already gone through those videos, you will know how do we write a function to find the middle of the linked list. We use 2 pointers, slow and fast, and how do we reverse a linked list. But even then, I'll go ahead with the pseudo code. So first thing is that your linked list is looking like this right now. Okay. This is pointing to null, right? Okay, so let's start off with finding the middle of the linked list. I want to find mid, so it will take a head node, it will take some node head. Okay, how do we find the middle of the linked list? We take 2 pointers, slow pointer pointing to head, fast pointer pointing to head, right? Then what do we do? This is your slow pointer. Let me show you the iteration. This is your slow pointer, this is your fast pointer pointing to head node. Unless your fast, while your, let me write the code first. So This will be kind of a recap for you if you have forgotten how do we find the mid. We use 2 pointers, slow and fast, in which fast moves by 2 nodes and slow moves by 1 node. So the first node to move to null would be your fast pointer. So while your fast is not equal to null and your fast is not fast dot next is also not equal to null. Fast dot next or fast dot next is not equal to null. In that case, move your slow by 1, slow dot next, and fast moves by fast dot next. Okay, so by the end of this loop you return slow pointer, which is actually the which actually points to the second mid. In case of even, this can also be treated as a mid pointer and this can be treated as a mid pointer, but with this method my slow will be pointing to the second mid. Let's see the iteration. In the first iteration, my fast goes here. This is where my fast is pointing to. Fast is here, slow is here. Okay, in the next iteration, fast becomes equal to null. Fast becomes equal to null and slow points at this point. Now fast is equal to null, so you will come out of the loop. Where is your slow pointer pointing to? This, right? Now you have the address of this node. So from here, once I get my slow pointer, I'll make a call to the reverse function. In reverse function, what do we do? So reverse function's task would be node head. And in this head, what am I actually passing? So you need to understand this thing. Now my slow pointer is pointing to this. I am actually passing slow pointer here. Why? Because I want the linked list starting from slow pointer till the end to be in reverse order. Now I am not going to write it because we have used it multiple times. In the previous question also we have used the reverse function. How do? We take a previous node which is pointing to this, then we take a current node, and then we take a temp node which points to the current dot next. Then we change the pointers in such a way that one will be pointing to 2, right? And now what will happen once I have made a call to reverse function? I will get something like this. See, I am going to get, after making a call to reverse function, this is how my linked list is going to look like. This 2 will be pointing to actually 1 and 1 will be pointing to 2, and then that is null. But what do I want is 1 is pointing to 2, 1 is pointing to 2. This is how it is going to typically look like, right? Am I doing it fine? 2's next is pointing to, and because I know that this thing once reversed, this link needs to be broken. You're getting my point? This link still needs to be broken. So in order to break this link, what I'm going to do, your slow is actually still 2, right? So 2's dot next should be equal to null. That's how this link will be broken. So once I come out of this reverse function, slow pointer will still be pointing to the node with whose value is 2. This is your slow pointer. I need to make sure that this looks like a new linked list whose new head is 1. You might be getting confused by looking at this. So the whole idea is that after you make a call to reverse function, your 1 will be pointing to 2, but 2's next is not going to be null because this is the link that is still present. So to break this link, what I'll do after I come out of the reverse function, slow is pointing to 2, right? Although it has been reversed, you will do slow dot next should be equal to null. Now what? Reverse function should be returning you a new head, which is actually now pointing to 1, right? Because it is the head of the reversed linked list. Now this is how 1 and 2 will look like, and this dot next will be null. This is your new head and this is your original head. Now you, after making call to these two functions, now you are simply checking while what? You have 2 pointers. One is temp, let's say at this, another one is current at the second link. You just simply check while one of the nodes is not null, okay, while temp is not equal to null, and this current should also not be equal to null. And now it's a simple thing. I'm just traversing over 2 linked lists, right, and checking if it's a mismatch, I return false. If temp dot data is not equal to current dot data, I return false. Return false. Otherwise, when you come out of the loop, if you have not hit the false condition, you go and return true. That means it was a palindrome. That's all. I hope you all understood this problem. So we have basically, what we have done, instead of using an extra space, we have just modified our linked list in order to use the same logic. The logic was to just compare. Since it's a linked list, I wanted to reverse it, and in order to reverse, I need to find a mid, which we know. That is why in previous lectures we have already taken questions in which we find mid and we reverse the linked list. Just making use of these two functions, this question has been easily solved. Got it? So if you will check, obviously we are taking more traversals. First, to find mid, I am traversing O of n. Obviously traversals are more, but we are not using any extra space. So on for finding mid, then plus on for finding not actually exact on by 2, but okay, predominantly it will be big O of n when we are reversing the second half of the linked list, right? And then again precisely on by 2, okay, but predominantly big O of n, to find if there's a mismatch. So in all, the time complexity will be big O of n, but space complexity is going to be O of 1, because we have not used any extra space. So that is the approach by which we have solved this question. I just want to check if we are, yes, okay. So that is all about it. If you guys have any doubts, you can ask me in the chat. And this is the code which you guys can see here. See, this is your function given to you, right? Within this function itself, I have used that instead of taking an extra function to find the middle of the linked list, I have written the logic right here. You can see that we have taken 2 pointers, slow and fast, and from here I have found the slow pointer, right, which I am passing to reverse the second half of the linked list, right? So this is the reverse function which I have written separately, in which I am passing the slow pointer, right, from where I want to reverse the second half of the linked list, and the new head that I will find after reversal, I have taken this variable, this name second half start, which is actually the head of the new reversed linked list. And why we are doing slow dot next equal to null? Because I have told you that to break the link to which slow is still pointing to its previous, the previous is still pointing to that slow, right? I'm sure once you try it on your own, you'll be able to understand why we have written this. Although I have already written the logic in the pseudocode, so it shouldn't be difficult to understand. Now nothing, just simple thing, the current and temp pointers that I took to help you understand. Here it's P1 and P2. While both of them, the condition is that none of them should be equal to null. Till then you compare the data. If you find a mismatch, return false. Otherwise you move to the next pointer and keep checking, and then finally you return true, right? This is your reverse function. Previous current, while current is not null, you're making the traversals, changing the links to the previous node, and then that is all about this problem. Let me know if you guys have any doubts. If there are no doubts, I'll wrap the lecture. Fine. So that was all for today, guys. I hope you understood the problem. Try to attempt it without seeing the code. If you have understood the logic, attempt it on your own. Okay? That's all then. Wrapping it up, guys. See you all in the next lecture. Bye bye and take care.